All right, I started recording. I started recording. All right, number one. So these are equations. So this is a combination of what we did last section plus this section. So tan x minus 1 equals 0. So I'm going to get tan x by itself. So tan x equals positive 1. And then x is equal tan negative 1, or if you remember, arctan.
What?
So, no, arctan.
It looks like log to me.
I can see where you see logs, but no. Now, remember, for sine and for tan, when you do the arc, it is between, like the arc one, is the domain is from negative pi over 2 to pi over 2.
No, that's sine and cosine. I mean,
Sine and tan.
So why'd you put
No, no. Tan.
You wrote sine and tan.
I did, but it was debated. And then cosine is the top two quadrants, so from 0 to pi. Okay, so I need, where is tan 1? What do I plug in to get tan to be 1? In this case, I could plug it into root 2 or pi over 4, or 45 degrees. 45 degrees is where tan equals 1. So it's going to be pi over 4.
Where does it show that 45 degrees is where?
Tan is, if you think of the unit circle, it's root 2 over 2, comma root 2 over 2.
How do you know that?
You have to know the unit circle.
Wait,
Or the triangle.
Tan 1 is root 2 over 2 over root 2 over 2.
Tan pi over 4, or tan 45 degrees, is root 2 over 2 divided by root 2 over 2, which is 1.
45, 45, 90 triangles. This is on the last test.
Yes, the only thing is you're doing a little algebra. Like this one's simple. We'll do the next one that shows you how it's different. But this question could have been on your last test realistically. Like it's just one step away from being on your last test. All right, number 10.
Wait.
Yeah, go ahead.
Sorry, you guys. So how did you get from, where does the pi over 4 come from?
So pi over 4 is a value that if I plugged into tan of x, I would get 1.
How do you know that though?
You got to know the unit circle, or it's 45 degrees.
What does pi over 4 mean?
45 degrees.
So why can you write 45 degrees?
When you do, it's kind of like decimal and percents. You can't work with percents, you work with decimals.
Okay.
In the same way, you can't work with degrees, you work with, right.
So you're solving for x, which has to be a radian?
Yes.
Wait.
Or your answer is in radian 4.
Wait. So x equals pi over 4?
Mm-hmm. All right, next one. All right, so next one, number 10. Cosine x plus 1 equals negative cosine x. Let's see what we could do. I'm going to bring,
2 cosine equals 1.
let's do 2 cosine. X plus 1 equals 0. Then minus 1 on both sides.
Oh,
2 cosine x equals negative 1. And then let's divide it by 2.
Yeah.
Cosine x equals negative a half.
That's the final answer?
No, because we need to find what x is.
Oh, fine. Oh, so you want to get the thingy alone.
Yes.
So you do cosine.
So x
So 60.
Like
cosine negative 1 of negative a half.
I don't appreciate that. I don't appreciate your I don't appreciate.
So then, what cosine value do you plug in here to get negative a half?
Oh wait, can I try? 60. It's 60 degrees is 1 half.
Yeah. So, but it's negative. So it's cosine. So it has to be in the second quadrant.
Oh, word. So it has to be.
Wait, how do you know it has to be in the second quadrant again?
Remember, cosine is from the first and
130.
the first and second
No,
quadrant.
not 130. 120.
120.
Wait, can it be in the first 3 though?
What's up?
Shake so
Can
loud
it be
with
in
the
the
cake.
third one too?
What's up?
Can it just be in the third one also? It can be in all of them except for.
It could be 2 and 3, but remember the antiderivative. Or I'm sorry, antiderivative. The inverse cosine or inside trig is only between
There's
the.
only 2, right?
Yeah.
Okay, so it's either like this or.
Yeah. So in this case, it would be, what do we say?
60.
120, which is 2 pi over 3.
Yeah.
So, because you subtracted 60 from 180.
Mm-hmm.
Got it.
Oh. Subtracted 60 from 80.
Yeah, because it's like 180 and 60.
Did you buy it?
What were you doing? You were just counting?
Yeah, you just.
I was.
How'd you get 120? That's not what you how'd you get 120?
That's what I was doing. I was like 60 plus 60 is 120.
That's very lucky, but that doesn't always happen.
Oh, no.
That just happens to be, yeah. Okay, next one.
Oh, wouldn't happen. Like, work with it?
Does that always work with 60s? Actually, technically does always work with 60s. That's funny, yeah.
Oh, okay.
Wait, does what always work with 60?
If you just kept adding 60 to get to the quadrant. Because the next one will be 240, which is correct. And then the next one will be 330, which is correct. Well, no. No, it'll be 300, which is correct, yeah. All right. Next one. 4 sine squared x minus 1 equals 0.
Yeah, I think it's gorgeous.
So plus 1.
No, it's all my friends.
4 sine squared x equals 1. Divided by 4. Divided by 4. Sine squared x equals 1/4. Square root both sides. Sine x equals 1/2. But remember when you square root both sides in an equation, what do you also have to include?
So he's so excited. Wait, is the denominator a 4?
They're both complete squares.
Yes, but when you square root on both sides, what answers could it be?
Plus minus.
Plus minus. So we can't forget the plus minus.
So that would have to be, I don't know.
So sine that causes a half. What value of sine causes a half?
30.
No,
30 degrees.
30.
Sine is 30 degrees.
She a hater.
Is 30 degrees will cause a sine to be a half. Cosine would be 60 degrees.
Wait,
Oh, no, yeah.
you draw the thing with the graph with 0 minus 180, 180 minus.
Sure, real quick.
0.
0. 180 minus theta, whatever your angle is. So I guess this is theta technically. Theta plus 180. And 360
wait, what?
minus theta.
Why did it, is the square root of 1/4 a half?
It is a half, but you remember, it's not only a half times a half, it's negative half times negative half. So we got to do the plus minus. So in this case, we need both places where it causes half, which is going to be in these quadrants, 1 and 3.
Wait, is a quarter squared 1/16?
Yeah. A quarter of a quarter is a 16th.
Oh.
So then it's going to be a half, which is 30 degrees, which is, no, you don't, you wrap around, you have to go down. So it's going to be pi over 3 and negative pi over 3.
Yeah, but would it be 360 minus?
Wait, why is it not pi over 6?
No, because remember, the answer is, it's 30 degrees. Oh yeah, you're right, it's pi over 6.
360 minus 30.
Oh yeah, because if it was 60,
330.
if it was
Wait,
60,
well, what's my
if it
answer?
was 60, if
6,
it was 60,
6.
then it would be
3.
You're letting Ali confuse you.
And then,
No, what?
and then from here, remember, our answers is negative pi over 2
Wait, what?
to pi over 2. Remember, that's our domain for sines. So it's not going around this way. You're not doing that. You're just going from here down.
Yeah.
That's why it's negative pi over 6.
So you're never gonna have anything. in
You're
there.
right about your previous thing where it's the coterminal angle of,
We
Would-
still have to find the. Oh, sorry.
Wait, can you explain why you get negative pi over 6 too?
remember, sines
Because it's a square root.
is these two domains, right? The first quadrant and the third quadrant, or the fourth quadrant.
So wouldn't that be 300 in the first quadrant?
300?
I'm not 300. I meant
330.
330.
That's what I'm saying.
No, because you're not, if it was 330, this is what you would be doing. You go around and hit here. We're not doing that. What we're doing is starting here and going down to here. So that's a negative root 6, or negative pi over 6. The route you're taking crosses through these, I guess, no man's zones over here and here. You can't do that. You have to stick it to your domain. Good. All right, 12.
Or you can give us like a cosecant, secant, and like.
Not on these ones. No. Not on
Not these things.
the inverse ones. No.
Maybe we should all study together.
Cosine squared
This
x
was one of the board I saw.
minus cosine x equals 0. So in this situation, you're like, this is impossible. But you realize they both have cosine, right? So I'm going to factor out cosine. So cosine
I have to put
x and cosine x minus 1. wait a second. When it looks like this,
For school, doesn't it?
if I had something like this,
On a Sunday?
you could solve this, right? Because you would split it as x and x minus 1.
That's the good stuff.
You could solve that.
I'm off for it.
It's the same concept. It's just with a cosine. So I could split and solve this
So you
and
just
set
factor.
this one, yeah, you would just factor. Which,
Cosine x equals 0.
and then cosine x,
So wait, but then x just equals cosine. Negative cosine. How does that-
cosine x, hold up, minus 1 equals 0. So this is cosine x equals negative 1.
Yeah, but
What?
oh wait, you don't separate on the left side. You don't take the x over to the other side.
Do I separate that?
I like make cosine equal to x.
Yeah, you do that here. So x equals cosine negative 1, 0. And x equals cosine negative 1, negative 1. Okay.
Is it a positive one?
Oh, yeah, you're right. It's possible. My fault. All right, with that in mind, we're going to find what 0 is, and we're going to find what 1 is. Well, cosine 0 would be where your x value is 0. So where is that on the
The middle origin.
it would be at the origin technically, but it's this, remember, it's this domain, right?
Well, it's like 0.
So it's going to be where x is 0. So at 90 degrees or pi over 2. So this one is pi over 2. And then over here, this is where cosine is positive 1. Cosine is positive 1. No, that'd be negative 1.
Oh.
So it's positive 1 just at 0 at the starting point. So this one is 0. So your answers are pi over 2 and 0. That's it.
Gotta be in here, bro.
Our class was
No, we gotta have class.